So this is standard 1.3. I'm doing problem 1.2. The problem gives 3 quantum states, which are shown right here. And the part A asks to find a normalized vector, which is phi, that is orthogonal to these psi's. So this part, the bra phi ket phi equals 1, is saying how it has to be normalized. And then this part is saying how it has to be orthogonal. So these are our 2 conditions that it has to meet. So first you start by setting phi 1 to alpha and beta. And then we can change it to ket phi by moving it to this type of matrix, and now it's alpha, the complex conjugate, and then beta, the complex conjugate. And so now when you multiply them, you get this. And so this is simple matrix multiplication, and you set it equal to 0, and then you get this, and you can solve this. And so now you know that the complex conjugate of beta is 1 over square root of 3. And then so this is your phi 1. And you do the same thing with phi 2, and you get 2 over the square root of 5 and 1 over the square root of 5. And the same thing with phi 3, and you get this. And you can check to make sure that they're normalized, like I did right here. And you can see that when you square them and then add them together, you do get 1. And if you look, these both follow that also. So part B is asking to calculate the inner products for psi I and psi j for I and j equal to 1, 2, and 3. So we already know that psi 1 and psi 1, and then psi 2 and psi 2, psi 3 and psi 3 are going to equal 1 because these are normalized already. So when you have normalized bra and kets, they equal 1. So that takes care of those 3. So for psi 1 and psi 2, all you really have to do is multiply the first part of each one together plus multiply the second part of each one together, and you get this. And we don't have to do that for psi 2, psi 1, because that's just the complex conjugate of psi 1, psi 2. So all we have to do is make the i's negative. So instead of 1 plus 2i square root of 2 over square root of 15, we have 1 minus 2i times square root of 2 over square root of 15. So that takes care of that one. And then we can do that for each of them, 2 and 3, 3, 2, and then 1, 3, 3, 1. So again, we multiply the first part of each one plus multiplying the second part of each one. For this one, the e to the I pi over 4 can be turned into negative 1 over square root of 2 plus I over square root of 2. And then when you simplify that, you get this. And then again, you just find the complex conjugate by turning the i's to negative. So in this case, minus 2i over square root of 2 becomes plus 2i over square root of 2. And then for 1, 3, again, you repeat the process, doing the same thing with e to the I pi over 4. You get this. You can simplify this down some more and you get 2 minus I over square root of 6. And then you find a complex conjugate to get 3, 1. And that becomes 2 plus I over square root of 6.